Okay, so these are the identity or not problems. So what we want to do is we want to graph the identity or the equation that we're given and see if it in fact is an identity. So what we're going to do is we're going to go to Desmos, and so our first one is sine 3 theta and we want to know if that's the same as 3 sine theta times the cosine of theta. And they don't appear to be. So since they don't appear to be, what we're going to do is give a counterexample to this. So to give a counterexample to this, what we need to do is find a place where they're not the same. So sometimes it's easier to think in degrees, so all I'm going to do is I'm going to convert this graph to degrees, and I'm going to make that say negative 360 and positive 360. And so what I want to do is find a spot where they're not the same. So this looks like a nice place. Well, that says 41. So maybe I'll go with 45. So I've got 45 for the green is 1.5, and for the blue, $707. Okay? So what I'm going to do is come back over here to my notes, and I'm going to show that this is not an identity. And I'm going to say theta equals 45 degrees. So I want the sine of 3 times 45 degrees, which is the sine of 135 degrees, which is the square root of 2 over 2. Or on my calculator, it was 0.707. And then I want to show this, that 3 times the sine of 45 times the cosine of 45. Well, that's 3 times the square root of 2 over 2 times the square root of 2 over 2, which is 3 times the square root of 4 over 4, which is 3 times 2 divided by 4, which is 6 over 4, which is 1.5. But these are not equal. So this is my counterexample. So then what I'm going to do is I'm going to go back to Desmos, and I'm going to type in the top equation here. I'm going to type cotangent x minus tan x, and then in the second equation I'm going to type in cosine 2x divided by the sine of x times the cosine of x. And that looks like an identity. Oops, let me just put my parentheses here. And that looks like an identity. So I'm going to come back over here and we're going to prove it. I know we don't like to use the P word, but we're going to prove this. So what we're going to do, all right, so we graphed it. Looks like it's an identity. So my first attempt here, I'm going to start on the left side, and I'm going to rewrite that in terms of sines and cosines. So cotangent is cosine x divided by sine x. And tangent is sine x divided by cosine x. And what I see here is that I have two fractions that are being subtracted. In order to subtract fractions, I have to have a common denominator. My common denominator could be sine x times cosine x. So I need to multiply this by sine x, and I multiply this by cosine x. Now when I do that and put those together, I have cosine x squared, or cosine squared x, over cosine x sine x minus sine squared x over cosine x sine x. Well, what I notice immediately is that the denominator on my right side is sine x cosine x, so I can rewrite that. And I can put this all as one big thing. So I now have cosine squared x minus sine squared x over sine x times cosine x. And so I'm looking at this and I know this means something. So I just get my handy dandy card out and I look and see, hey, cosine 2a is cosine squared a minus sine squared a. So that means that all of that equals cosine 2x. And that's my proof.